Hi friends, may peace and blessings be on you. This video is by Physics Hunters. Hunt your physics related content in Physics Hunters. I would like to initiate with a quote. Knowledge is power, out of which power is rate of doing work. Work more, gain more. Today's topic is about refraction through the prism. What is a prism actually? Prism is a three-dimensional object. Prism is said to be a three-dimensional object which you can see here. So the triangular prism is taken in which for the consideration I am taking only one face of the prism for discussing the refraction through the glass prism. So let us take the glass prism here in which I am taking only A, B, C, one face of the prism, in which if I allow an incident ray to fall on one face of the prism, it gets refracted in such a way that from the rarer medium to the denser medium it bends towards the normal, and then from denser to rarer again it bends away from the normal. If you extend the incident ray and the emergent ray, it will give you an angle called as delta, where delta is the angle of deviation. So this is a simple logic that we are going to discuss about. So if for the derivation purpose, if I want to discuss what is your refraction through the glass prism, right? So here you can be able to see the prism where a ray PQ is the incident ray. This PQ is going to be the incident ray, and at the Q you are drawing the normal to the face AB. From rarer medium to the denser medium, it bends towards the normal. So it bends towards the normal. And after that, from denser to the rarer medium again, it should bend away from the normal. So before drawing the normal, before drawing the refracted ray, second refracted ray, just to draw the normal, right? So this is your normal that is drawn here. So let it be n dash to differentiate it. And from denser to rarer, it bends away from the normal. This is a path of the light ray that falls through the prism. You can be able to see how the path is getting deviated. If you extend the incident ray and the emergent ray, so this is your incident ray, right, and this is your refracted ray, and this is your emergent ray, totally emerged out from the prism. This incident ray and the emergent ray, imaginarily when we make an angle to meet at a certain angle, this angle will give you the idea that delta will show you the angle of deviation. This will give you the idea of angle of deviation, how much the incident ray is getting deviated. So the incident ray has to go through like this, but you can be able to see that due to the refraction from rarer to denser medium, it gets refracted and then again it is getting emerged totally out of it. So if you extend the emergent ray and the incident ray, it will give you an angle of deviation, right? So let me mark all the angles for our consideration now. So this is P, PQ is the incident ray, Q, and this point we call it as R, and this is as S. So PQRS is a ray, light ray that is passing through the prism. And N is a normal and N dash is a normal that is drawn on AB and AC respectively. And you know that if I make the extension in such a way that make these two normals join at here to make a particular angle over here. Say, let me make this angle as say O. Right? So you can be able to see that here, or you can be able to name this as say N, right? Because they both are normal only. So this is as N. So this normal which is called as N, and it forms now, you can be able to see here this A Q N R. What is this A Q N R shape? this angle AQNR is nothing but it is a quadrilateral. AQNR is nothing but it is a quadrilateral. So if you see about it, property of a quadrilateral says angle A plus angle QNR, the opposite angles are 180 degree. Angle A plus angle QNR. So you can be able to say this angle A and this angle QNR will be equivalent to 180 degree. Consider this angle, this equation as number 1. And if you take this QNR alone, it seems to be a triangle. You can be able to see the triangle that is formed over here, QNR. This QNR, if you see this triangle, let me mark this as say R1, and this one as, actually you know that you have to mark it as incident ray when falling at the point of incidence. This should be angle of incidence, and this is your refracted angle. And you know that when it is totally emerged out of it, the angle between the normal and the emergent ray will give you angle of emergence. So that this I am just naming it as R2. Actually this R2 is nothing but angle of incidence 2. But I am naming just like R2 to make it more comfortable. So R1, R2E. And then you mark this angle as 1 and this angle as 2. And of course you know that this is your angle of deviation delta. Right? So now we have marked all the angles. Now we are going to apply all the geometrical concepts. So now you take, now first of all we have taken a quadrilateral and we have obtained the relationship. And now you take a triangle QNR. Triangle QNR in the sense sum of all the angles are 180 degree. So you can write it as angle QNR plus R1 plus R2 is equal to 180 degree. Right? And if you see the comparison between these two, first and second equation, you can say that angle QNR 180 degree all are same, and you will come to the conclusion that angle A is equal to R1 plus R2. Make this angle as an equation 3. And now apply the equation exterior angle property to find out delta. How to find out delta here? Delta, this exterior angle delta is nothing but, right? So this delta is equivalent to angle 1 plus angle 2. So you can consider now delta is equal to, applying the exterior angle property, you will be getting angle 1 plus angle 2. Right? So now you have to find out what is angle 1, angle 2. For that what you are doing, now angle I you have to find it out. If I want to find out angle I, right? So I is nothing but, this is your vertical opposite. So you will be writing it as angle 1 plus R1. So that angle 1 is equal to I minus R1. Right? So make this. Right? And similarly, angle E is equal to angle 2 plus R2. Same property you are applying. What is angle 2? You are getting it angle E minus R2 or E minus R2. Now substitute this in delta. This implies delta is equal to what is angle 1? I minus R1. What is angle 2? E minus R2. So you can write it as I minus E minus R1 plus R2. According to the third equation, what is R1 plus R2? Third equation says R1 plus R2 is A. So you can write it as I plus E minus A. Right? So consider this equation as number 4. Keep this equation as number 4. Now the thing is, as angle I changes, we are keep on increasing the angle of incidence. Now what we are trying to do is, first we have done, this is your angle of incidence, incident ray, and I am keep on increasing or decreasing, changing the angle of incidence. So if I keep on changing the angle of incidence, then the angle of deviation also varies. That is my conclusion. So if I changes, the delta also changes. The angle of deviation also changes. At one point, this I will become equivalent to E. right? That I will become equivalent to E. So in that thing, after this value, this delta value again start decrease. This can be beautifully understandable by the graph between delta and I. First, what happens as angle of incidence increases, the delta starts decreasing. At one particular point, this point where it becomes I is equal to E, after this point, the delta will be start increasing again. So this property that we can see here, we can substitute it I is equal to E. So your fourth equation will become delta is equal to, since I and E are equal, you substitute as I plus I minus A, which is 2I minus A. So from that, what is I? A plus delta divided by 2. Now we got what is I. And as I said here, when I is equal to E, that means this implies from the diagram PQ and RS are parallel to each other. So if they are parallel, you can be able to see in the diagram here, if they are parallel. Say if they are parallel here, R1 and R2 are same, right? So we can come to that conclusion in that thing. If PQ and RS are parallel, R1 is equal to R2 is equal to R. So I can write it as, from the equation 3, that A is equal to 2R, in which R is nothing but A by 2. Now I got what is I, what is R. So what is the next thing? To find out the refractive index. So what is your Snell's law says? Right? Snell's law says that mu is equal to sin I divided by sin R. So in that thing, if I say sin A plus delta by 2 divided by sin A by 2. This equation we call this as Prism formula. This we call it as Prism formula to find out the refractive index of the formula. Now with the same help of Snell's law, since the angles are very small, this in the first refraction it is called as sin I1 by sin R1, which is nothing but I1 by R1. Right? And now in the thing, if you see about it, I1 is equal to mu R1, you will be getting it. In the same way, if you try to find out in the second refraction, where mu is equal to sin E divided by sin R2, then E is equal to, by approximation, sin theta into theta, you will be getting E is equal to mu R2. So from the equation delta is equal to I plus E minus A, you will be getting it as, what is I? Mu R1. What is E? Mu R2 minus A. So if you take this mu outside, mu into R1 plus R2 minus A. What is R1 plus R2? Mu A minus A. Right? So if you take A outside, you can write it as mu minus 1 into A. So you can be able to give the relation for the angle of deviation, the final equation, as mu minus 1 into A. This gives you the idea that as refractive index increases, the angle of deviation also increases. So both are directly proportional to each other. So I would like to end the session with saying that keep on revise the concept, write and practice, and continuous work will lead to the success.